have you ever felt that shiver down your spine? The one that feels like more than just being cold?
Or maybe like a weird buzz of energy during a big thunderstorm.
Exactly. Well, imagine a time, and it wasn't that long ago, when science was really just starting to figure out these invisible forces.
Hmm.
The ones that might actually, well, animate us.
A time when that line between what we knew and what was completely mysterious was pretty thin. Exciting, maybe a little scary too.
Yeah, absolutely. So today, we're doing a deep dive into this really fascinating document. It's a lecture from 1843
Okay.
by a Dr. Robert W. Gibbes, a physician down in South Carolina. And he's exploring something he calls the magnetism of the human body.
Oh, wow. Sounds intriguing.
It really is. It's packed with his own experiments, some frankly incredible stories, and these really bold theories trying to explain, well, everything from headaches to healing.
And what's great about Gibbs reading this is his commitment. He quotes Bacon right at the start, about sticking to the facts of nature, not the theories of man. So our mission today really is to follow his thinking, his journey into how they understood electricity, galvanism. That's like early battery type electricity from chemicals, and magnetism back then.
And how these forces were thought to connect with the human body, especially through things like mesmerism or animal magnetism, as it was called.
Exactly. It's a fantastic look back at how scientists first started getting curious about these, invisible energies inside us.
So Gibbs got really hooked on this after looking into mesmerism, that whole idea where one person could supposedly exert this, like, powerful physical influence over someone else.
Yeah, manipulating some kind of invisible fluid, they thought, leading to some pretty strange effects on mind and body.
But Gibbs, he wasn't just going to watch. He wanted to actually test it, to see if the human body itself had, magnetic properties.
Yeah, he'd heard these claims, like during that weird cataleptic state mesmerism could induce, people's heads and hands were apparently attracted to magnets.
Seriously.
Yeah. And some even thought the brain itself had polarity. One side attracts, the other repels.
Okay, so what did Gibbs do? He tried it himself.
He did. He took a strong magnet, placed the North Pole near the upper forehead on the right side, and the subject felt a sensation of being pushed away. Then he tried the other side, the left side, and it was a pulling feeling.
Wow. And the South Pole.
Did the exact opposite. Pulling on the right, pushing on the left. And he didn't just do this once.
No.
He repeated it on 7 of 8 different people who were susceptible, including 2 young women who felt it even when they were fully awake, and he made sure it wasn't, deception.
That's pretty convincing for 1843, isn't it?
It certainly was for him. It led him straight to this conviction. The human body is magnetic. It has polarity.
Okay, so if he was so convinced and had this evidence, why wasn't it just accepted? What was the holdup?
Well, that was the big hurdle. The scientific bigwigs of the day, like Professor Henry at Princeton.
Leisure figure.
Right. They denied it because the reciprocal influence hadn't been shown.
Meaning the body affecting a magnet back.
Exactly. That had never been proven satisfactorily. Professor Henry basically said, nope, that branch of science just doesn't exist. Full stop.
Ouch. But Gibbs thought he cracked it.
He did. He claimed he'd found a method for showing upon the needle directly the magnetic polarity of the human body. He really thought studying the nervous system's magnetic properties would unlock the secrets of animal magnetism.
So what was his method? How did he show it?
Well, he describes it. He'd make this strong effort like he was throwing off something from the fingers, real concentration.
Okay.
Then he'd carefully bring his fingers near a very delicate magnetic needle, being super careful about air currents.
All right, did it work?
He says it did. His right hand repelled the north pole of the needle, which meant to him north polarity in that hand.
And the left?
Opposite polarity. It repelled the south pole, attracted the north. He said the effect was brief, just momentary, but definitely there. And he was adamant it wasn't just a puff of air.
So that was his proof.
For him, it was huge, a direct experiment. It suggested we don't just feel magnets, we can generate magnetism. And it seemed tied to muscle action, maybe even willpower.
That's a pretty big leap. Challenging the establishment directly.
Absolutely. And he didn't just stop with magnets.
Right. You mentioned electricity and galvanism, too.
Yeah, he dives into that whole discussion. A lot of scientists back then thought magnetism, electricity, galvanism, they were all kind of different aspects of the same fundamental force.
Okay. And people generally knew we were electric, didn't they? Even back then.
Oh yeah, common knowledge to some extent. He mentions the sparks you get taking off flannel or silk clothes in dry weather.
Or stroking a cat. I still get that sometimes.
Exactly. He even had this idea that maybe people who didn't sweat much, who had deficient perspiratory function, might build up more electricity on their skin.
Huh. Makes a weird kind of sense. But then he shares some really wild stories, doesn't he?
Oh, absolutely extraordinary accounts. Get this. A lady in 1837 during the Northern Lights became so electrically charged that for months afterwards, she gave off vivid electrical sparks from the end of each finger to the face of each of the company present.
No way. For months. That must have been awful.
He said it was incredibly vexing. She couldn't touch metal without getting a spark and a twinge. Imagine trying to open a door.
Or just shake hands. Wow. Any others?
Yeah, another gentleman's wife who apparently attracted fireflies around her in the dark.
Fireflies? Seriously?
That's what he reports, and she was annoyed by sparks around her too. And then there's So Sure, the geologist, climbing in the Alps,
Okay.
got caught in thunderclouds, and he and his buddies found their bodies basically filled with electricity. Sparks shooting off them with crackling noises, even painful sensations. Larry reported something similar with horses' manes in extreme cold in Egypt.
So the environment, the atmosphere, played a huge role in their thinking.
Definitely. If we're electric, then external conditions must affect us, right? He talks about winds like the Sirocco in Europe or the summer southeast wind here.
Making people feel sluggish. Lassitude, he calls it.
Yeah, because the idea was the atmosphere was deprived of electricity during those winds, but a north or west wind, that restores energy.
People still say things like that today, don't they? About how the weather affects their mood or energy?
They absolutely do. And Gibbes had a personal case too. A young woman struck by lightning.
Oh, dear. Was she okay?
She survived, but had lasting issues, couldn't tolerate light, had spasms, and she felt very much oppressed whenever rain clouds passed overhead. Then, during an actual storm, she'd have violent spasms again.
Wow. Like her body was directly tuned in to the atmospheric electricity.
That was exactly the perception, a direct, almost painful link between the weather's electricity and human health.
So were they starting to think that life itself was fundamentally electrical?
That was the really big question driving a lot of this. People like Sir Humphrey Davy thought animal heat might just be electricity. Maybe the same thing as the nervous fluid they talked about.
Nervous fluid.
Yeah, the sort of hypothetical substance they thought transmitted nerve signals. And experiments by Prevost and Dumas suggested muscle contractions. Even things like secretion glands producing substances worked kind of like an electric pile, like a battery.
Creating acids and alkalis, changing substances.
Exactly. Like biological processes were fundamentally electrochemical.
And the amount of electricity involved.
Oh.
You mentioned something staggering.
Right. Professor Miller in Baltimore found that just passing electricity through dark venous blood could turn it into bright red arterial blood.
Okay, that's pretty amazing.
But then Pouillet did these calculations based on just the carbonic acid produced during breathing.
Yeah.
He estimated the human body could generate enough electricity every single day to charge 333 standard Leyden jars.
333. Just from breathing.
That was the calculation. Leyden jars were early capacitors, ways to store charge. It implies this huge amount of internal electrical activity constantly happening.
Mind-blowing. And they saw this galvanism, this chemical electricity, in animals too, even without metal.
Yes. Several examples. Humboldt found frog muscles twitch if you just touch the nerve and muscle together with another piece of fresh muscle. No metals needed. Bunsen even made little galvanic piles like tiny batteries, just using alternating layers of muscle and nerve tissue.
Seriously.
And Dr. Don found that the body's membranes, like the acidic exterior skin and the more alkaline internal membranes, acted like the poles of a galvanic pile. He could actually measure a current with a galvanometer.
So the body itself was seen as this complex electrical thing.
Precisely. Which leads us naturally to nature's own shocking examples.
Ah, the electric fish. Like the torpedo ray and the electric eel.
Exactly. For Gibbes, these were like living proof. Biological systems that could obviously generate powerful electrical discharges can't argue with an eel that knocks you flat, right?
And the key thing was, this power was voluntary.
Completely. It depended entirely on the nerves being intact. If you destroyed the fish's brain or cut the specific nerves going to the electric organs, the power just stopped.
Someone check this.
Oh yeah. Professor Ellett, right there at the South Carolina College, worked with a 4-foot gymnotus, that's the electric eel, and personally confirmed it could shock voluntarily.
Right.
He even got a spark from it.
Wow. And there was that other researcher, Mateichi.
Yes, Matochi did a ton of work, experimented on over 100 torpedoes. He found their electric power actually increased if their circulation and breathing sped up.
Okay, that links it to biological activity.
Definitely. And he did this one really striking experiment. He had a tiny, weak torpedo, put it under a glass bell filled with pure oxygen.
And what happened?
It got really agitated, gave off 5 or 6 strong shocks, much stronger than before, and then it just died.
Whoa. Like it burned itself out using the oxygen and electricity.
That's how it seemed. An incredible, if grim, demonstration of that link. Biology, oxygen, electricity, all tied together. He also showed if you cut the nerves on just one side of the electric organs.
Let me guess, that side stopped working.
Exactly. Only the side with intact nerves could discharge, which made them think about things like human paralysis, maybe similar nerve disruptions.
And did they figure out where in the fish this control came from?
Mateucci pinpointed it. The main control center was the last lobe of the brain, what he called a swelling of the elongated marrow.
Which is like our...
Our medulla oblongata, basically.
Yeah.
The lower part of the brainstem that controls vital functions and where many motor nerves originate.
Okay.
And crucially, Medici found no electricity in the fish except when it was actively discharging.
Ah, so it wasn't constantly on. It was an active willed process tied to movement or intent.
Precisely. Supporting that idea of voluntary control, only active during muscular action.
And someone connected this to human nerves.
Yeah, Dr. Carpenter drew a parallel. He compared those electric nerves in fish to our own 8th cranial nerve, the par vagum.
The vagus nerve, we call it now.
Right, the one that connects to the heart, lungs, stomach. Super important and heavily influenced by emotions, fear, anger, you name it.
And Carpenter noted something about hydrophobia, rabies.
He did. In cases of hydrophobia where nervous energy is pathologically heightened, they found damage, lesions, right in that vagus nerve area.
Suggesting this deep link between our emotions, our nervous system, and maybe this underlying electrical activity going way back in evolution.
Exactly. It's all starting to weave together.
So building on that, Gibbes then really digs into this connection between nervous power and the will, right?
Yeah. So Charles Bell had already shown that different spinal nerve roots had different jobs, posterior for sensation, anterior for motion.
The inputs and outputs, basically.
Kind of. And some are theorizing, okay, maybe there are ascending and descending electric currents in the spinal cord. One direction for feeling things, the other for making muscles move.
And Muller's experiments seem to back that up.
They did. He applied galvanism, that chemical electricity, directly to the anterior nerve roots, the motion ones, and got these violent muscle twitches. It supported Bell's idea about function.
But then Gibbes mentioned some, well, frankly, quite disturbing experiments. Weinhold and the beheaded cats.
Ah, yes. Those are definitely arresting. Weinhold waited until the cats showed absolutely no signs of life. Then he removed the spinal cord.
Okay.
And filled the empty vertebral canal with this metallic mixture, an amalgam of mercury, zinc, and silver.
What happened?
Immediately, the arteries started throbbing again, muscles contracted, and the cat's body apparently made many leaps.
Oh my God. That's unsettling.
It gets weirder. In another cat, he filled both the spinal canal and the cranial cavity where the brain was.
Oh.
The body became vitally tense for about 20 minutes. It raised its head, opened its eyes, seemed to look around steadily, and even tried to walk.
That's pure Frankenstein territory.
It really sounds like it, doesn't it?
Yeah.
But for Gibbes and others, this was seen as powerful, maybe shocking evidence for the electrical basis of life and motion.
I can see why.
Yeah.
But was any of this actually useful? Did it lead to medical treatments?
Well, that was the hope. And Gibbes cites a couple of really dramatic cases where electromagnetism, using these new batteries, apparently saved lives.
Like what?
One was at Middlesex Hospital, a man dying from a laudanum overdose, that's opium tincture. They applied powerful electromagnetic shocks to his neck and near his heart.
Did it work?
According to the report, it stimulated his breathing, his pulse improved, and he recovered.
Incredible. And the other case?
Happened in Valparaiso. A guy poisoned with some powder laced with opium. He was basically at death's door. Dr. Page used an electromagnetic battery on him. The man's eyes flew open, he groaned, and later said it felt as if a gun had been fired off within him, but he survived.
Wow. So real-world applications, potentially life-saving ones.
They even mentioned successfully resuscitating drowned puppies with a voltaic battery, so yeah, the potential seemed enormous.
Okay, so how does Gibbes tie all this electricity, magnetism, galvanism back to mesmerism where he started?
Well, he makes a connection pretty directly. He deduces that people with stronger magnetic power, maybe more inherent electricity, can essentially charge weaker individuals.
And control their will and actions through this charge.
That's the idea. He shares more anecdotes to support this, like an editor whose subject was put into a trance just by touching a steel ring couldn't be woken up until she came out of it with a shudder,
Hmm.
or a minister's teenage son, mesmerized with a horseshoe magnet. Afterwards, supposedly, he could just know exactly where that magnet was hidden, like 70 or 80 feet away, even describing it wrapped in paper inside a pile of lumber.
That sounds, well, supernatural.
It does. And then there's Caspar Hauser, the famous wild child who was isolated for years.
Right, I've heard of them.
Hauser described these odd sensations like being drawn towards magnets or hidden metals, feeling chills, even his veins swelling when near them.
Adding to this idea of extreme sensitivity in some people.
Exactly. And even a surveyor who noticed his compass needle acting funny whenever he got close to it in dry weather, suggesting his own body was influencing it.
So, Gibbes is weaving together experimental data, these dramatic anecdotes, and reports of extreme sensitivity.
To build this case that there's a real physical, probably electromagnetic force at play in mesmerism and in the body generally, which led him to ponder, what is this nervous power, really?
Okay, what did you conclude about that?
He notes it seems to be under our conscious control, our will, when it comes to voluntary actions, moving muscles, animal life, as he calls it, but not for organic life like digestion or heartbeat. Those run automatically.
Makes sense.
And he brings up Coleridge's point. The mind can feel strong even when the body is weak, like when you're in pain but can still think clearly. But the nervous power itself, that gets used up.
By activity, pain, lack of sleep.
Right. And it gets restored by rest. He even touches on mental illness, suggesting maybe it's not the mind itself that's broken. He saw the mind as maybe indestructible, but the physical organs, the brain, that are disordered.
That's quite a modern thought for 1843, in a way, thinking about the biological basis of mental conditions.
It is. And he emphasizes again that people just vary. Some are naturally more sensitive.
More susceptible to mesmerism or atmospheric changes.
Yeah, and they seem to use up or part with their nervous power more quickly. He even mentioned some people finding the mere touch of metal painful or causing temporary paralysis.
Showing just how differently individuals might experience these proposed forces.
Exactly. It wasn't a one-size-fits-all theory.
Okay, so after laying all this out, the experiments, the anecdotes, the theories, what were Dr. Gibbes's main takeaways, his big conclusions?
He boils it down to 6 key deductions, basically.
Let's hear them.
1, the human body is magnetic and has polarity. 2, stronger magnetic people can charge weaker ones, controlling their will.
Okay.
3, our will directs this magnetic force. 4, like iron can be magnetized, people can gain magnetism from others and lose it when the source is gone.
Right, like a temporary effect.
5, once someone's been affected, they become more susceptible next time.
Kind of like priming them.
Yeah. And finally, 6, things like temperament, physical constitution, current circumstances, they all modify this human magnetism.
So a fairly comprehensive model he built there, based on his observations.
It was. And looking back, you see Gibbes as part of this bigger scientific moment. His contemporaries, people like Dr. Holland, Dr. Carpenter, they felt science was right on the edge of something huge.
A big discovery.
Yeah, they sensed all the different sciences, physics, chemistry, biology were converging. Maybe they could find one single principle, common laws, that explained everything.
Light, heat, electricity, magnetism, even life itself.
That was the dream. Proving the unity of creation, as they sometimes put it. Gibbes was right in the thick of that quest, trying to fit human experience into that grand, unified picture.
It reflects that deep drive in science, doesn't it? To find the underlying connections.
It really does. A drive that's still with us, even if the specific theories change.
And Gibbes himself, what was his final message?
He really just pleaded for open-mindedness. He kind of lamented the pride of arrogant man who would just dismiss these kinds of investigations out of hand.
Don't just reject it because it sounds strange.
Exactly. He quoted Bacon again. Don't read just to argue or just to blindly accept, but to weigh and consider.
That's good advice for any time, really.
Absolutely.
So thinking about Gibbes's lecture from way back in 1843, it's this really bold attempt, isn't it? Trying to connect our inner lives, thoughts, feelings, health, to these big physical forces of the universe.
Yeah.
Electricity, magnetism.
A courageous effort to bridge the known and the unknown.
And it makes you wonder, today, with all our sophisticated neuroscience, our deep understanding of electromagnetism, what connections are we still missing?
Mm.
What fundamental links between our minds, our bodies, and the physical world around us are we only just beginning to, you know, weigh and consider?
That's a great question.
Are there still invisible forces, subtle influences that we're currently blind to, just waiting for the next Gibbs or maybe the next Faraday
Yeah.
to come along and help us see them?